In this lesson, we're going to continue learning about the law of sines, which you see here from the previous video. If you did not watch that video, I would watch it first. So this is an example of a more traditional question that would be on a standardized test or a college placement test, where they just give you information, and then they would probably say something like, find side A. And they might not even say side, they might just say find A, and you would know that that was side A because it was lowercase. So let's just start off by drawing a triangle. So here we go. I'm drawing a triangle. And let's just start with, where do you think I should put the 92 degrees, right? This is about 92-ish degrees. It would not make sense to put the 92 down there. And then you just label it appropriately, A, B, C. So A, B, and C. Now, it doesn't really super matter. You're trying to just get a picture for yourself, but I like to be relatively close so the answers make sense to my triangle. So now that I put angle C is 92, AB is 11 feet, it is important to include your units on your triangle so that when you have your answer, when I find A, I will know to put feet on it. And this AB here is also what we would call little c. And then angle B is 65 degrees. Now, looking at this, since we're using the law of sines, our job is to find a contained angle in sides, right? So I have it right here. My angle contains the side 11 feet. And that makes our key ratio. And in this case, it's C. So I'm starting here, right? But basically, I'm going to use 11 divided by sine of 92 degrees for everything in this problem. I'm going to start by finding A, and then, so I'm going to start by finding what it asks for. So A would be A over sine of A, and we're going to need to find the angle by simply using geometry. So if I come to Desmos or another calculator, and I simply add 92 plus the other angle 65, that will give me the sum of the two angles. And every triangle in the universe has 180 degrees. That was revolutionary to know that in human history. It allows us to build. That would mean if I take the sum of the other two and subtract from 180, I get 23. Again, a check for some people who want to make sure you take 92 plus 65 and add 23, you know you have 180 degrees. So if this is 23 degrees, I then would use that to find here. And again, the relationship we're looking for in this is the idea that I have an angle across from what they're asking me for. They're asking me for side A. It could have also asked for CB. It just depends on who writes the problem. So if I cross multiply this, you're going to want to maintain the variable in front of the trig function. And in general, right, in general, I like to just put my sides in front of my trig functions for consistency. And also, if I put the 11 over here, like, what is that? You know, it gets confused with the 23. So put your side in front of your trig function. Then to get rid of this, you can divide, right? Because division will cancel the multiplication, and then you divide by sine of 92 on both sides to allow yourself to maintain that algebra relationship of whatever I do to the left, I must do to the right. And that'll give us the answer, which of course we're going to type into Desmos. So let's take a look at that. Go into Desmos again, and just make sure when you do it, you can put a multiplication sign there if you want. You can put a parentheses sign in there if you want. You don't have to. Just make sure when you divide that, see what happens if I don't highlight it? You need to highlight it, then divide it. Just make sure you have what you have on your paper in your calculator. And you can do this on a TI-83 or what have you. It doesn't, you know, either way is fine. So we end up getting 4.3. If we round that to 3 decimal places, it would still be 4.3. Actually, it would be 4.0, sorry, 4.304. Okay, and so that would be also in feet. Okay, so if this were a multiple choice problem, and if this were asking just for one part, then we would in fact be done. Our directions on our homework were to solve the triangle. So we're going to need to solve the triangle. And in order to solve the triangle, we are going to find the other side, little b. All right, so we're going to use the same key ratio here to do both parts of the problem. So I'm going to come over here and do 11 divided by sine of 92. Again, it's the exact same ratio. Here I'm going to do little b, but instead I'm going to have sine of 65. And the reason I'm doing 65, again, let's just, if you have a highlighter, it can be really helpful on a test. Little b is correlating directly across from 65 degrees. So then I cross multiply. Again, I let my variable will be on the left side. I let my sides be in front of my trig function. So b is a side, so is 11. Okay, and then I just divide. Again, very similar problem. It should feel fairly reasonable, possibly the easiest thing in the whole unit, in my opinion, because you're just looking at a consistent multiplication ratio and then a consistent division. All right, so I'm just going to type that in the calculator as well. So that would be 11 sine 65. Again, let me show you this again. Oops, sometimes it works and sometimes it doesn't. So be careful how you type in. Just make sure you're seeing what you think you should be seeing. And that would be 9.97. I'm actually seeing right there, I made a little typo. Look at that. Let's see if it changes it much. So that would be 4.301. So be careful, things like that. It's interesting how, you know, especially if you're thinking about other things or talking like I am while I'm writing, you can make little boo-boos. So just be careful. So again, I made a little typo there. I double checked it. The reason I was able to check it is if you notice, not much changes, right? So just be careful. And so this one came out to 9.975. And again, since we're looking at a side, this would be feet. Okay, so the next example is a word problem. Let me give you just a second to kind of read it over and see what you think. All right. Now looking at that, what we're looking for here, it's kind of interesting, is we're actually looking for everything in the problem, because when we read it, you know, they give us a diagram, fill in some stuff for us, but what they're asking for is the total distance in the flight. And the total distance in the flight is the perimeter, right? And if it wants me to find the perimeter, that actually means, guess what? Solve the triangle, which is no big deal because we've been doing that. So since they provided us a diagram, let's just fill in the other pieces. Okay, so this is 80 miles northwest. So you can see that right there. To avoid a storm, he makes a turn, then he returns to his original location. Okay, the diagram of this flight course is shown to the left, this picture. And so what we need to do now is the same kind of idea. I'm going to start with like, what is this angle right here? All right, so to find that angle, I'm going to get out my Desmos again, and I'm going to take 108 degrees and then add it to 15. This is maybe the first time I've ever seen them put an angle outside of the triangle here. And the reason they're doing that is they can't write it in there. I mean, they could have written it in there, but they do that sometimes. So just be careful. 180 minus 123. So that angle right there will be 57 degrees. Okay. All right. So now that I know that that's 57, what I'm going to do is I'm now going to set up my key ratio. So it maybe is a little hard to see because of the way in which this triangle was written, but the 57 degrees I just found is directly across from the 80. Okay. So that is my key ratio. 80 divided by sine of 57 degrees will be what I use for the entire problem. So let's just start with this side. This is not labeled, so you can call it whatever you want. I'm going to call this one X and call this one Y. It is not super important. You could also, if you wanted to, you could make up your labels. You could call this A, this B, and this C. Why don't we stick with that? But you know, sometimes it could be labeled X and Y. So this would be little b, and this would be little c, and this is little a. So let's find little b first, just alphabetical order. So little b would be proportional to its angle of sine of 108. And since we're going to be using this key ratio right here for the next part of the problem, we might as well just go ahead and set it up. Sometimes just doing them already set up is very helpful. And many times on assessments, that's what they're looking for, is the setup. So this would be C and divided by its proportion, its relationship to its angle. And just in case you need the highlighting, B was this one, so B and 108, and then C would be C and 15. And of course, they put it outside the triangle just to be annoying, honestly. All right, so here we're going to cross multiply, and that would give me B sine 57 degrees is equal to 80 sine 108, and just double check to make sure you put your coefficients as the sides, and same thing you've been doing. You're going to divide just like you've been doing. All right, and we'll go ahead and type that in our calculator and figure out what that is. Thinking about units before we write it down, sometimes it's good to put the units in. This is going to be miles, whatever we get. All right, so let's see. So we're going to type in here 80 and then divide it by sine of 108. Going to divide, make sure it didn't do anything weird with the division, and then sine of 57, and that gives us 90.720 miles. Makes sense. We're talking about a plane here. So the answers do need to make sense. 90 miles in flight, that makes sense. All right, so this one's going to be very similar here. It's just going to have different things and different positions and different letters. Make sure your side is first. And then we're going to divide. Okay. And then we're going to type this in the calculator. And again, it will also be miles. Now we're not done, so don't turn the video off once I do this. You need to see the important part of how we can do 90% of a word problem correctly and then mess it up. So in that case, I put a parentheses around the whole thing. It does not matter, though. It doesn't like that I don't have a denominator. I mean, just be careful what you're typing, right? If you don't like it, you could just backspace or whatever you need to do. So in this case, we got 24.688. If I round that to 3 decimal places, though, it would be 690. So 24.690 if I were to round it to 3 decimal places. And the reason, again, some people have been asking me about rounding. That 5, sorry, it'd be 89, would make that a 9. Oops, I missed solid, I guess. So that would be 89. Okay, so you don't over focus on rounding, but we do need to talk about it as you move forward, possibly to college. You don't need to know how to round stuff. So that 5 would make that a 9. And it'd be 689. Okay, so are we done? Well, if I go back and put this on here, B is 90 something miles. Just doing that for estimation. And this one is 24 something miles. And the plane is flying this whole thing. So the question is, what is the flight path? The flight path is not this long side. The flight path is all of it. So to find the total distance, what I'm going to do is I'm just simply going to take these 3 things and add them together. So we're going to take the original answer, which was 80 miles, and don't use that. I just wrote that to save time. You're going to want to actually put all of them in. And if you're using a calculator like this, you can just, boop, just copy them on in there, right? So 195.409 miles. I'm going to tell you something about rounding here in a second, actually, because you don't need to think too much about it. We're not going to be super, crazy about how we do this, but it is important to understand that when I did this, I actually used 7 decimal places. So your answer might be a little different than mine there. That's why we typically on a test would just go to the 10th. If we go to the 10th, it's a whole lot easier. You would just be 7 here and 7 there, and then you'd add it up. So let's see what would happen if we went to the 10th place, just for fun. It does not change it in this case. It does sometimes change it. So I like to go more decimal places just so that if they ask me for tenths, the tenths would be right. All right, so that's the end of that. And if you're wondering, like, why don't we talk about angles? Like, why didn't we do inverse sine and find any angles? That's actually the second day, which is when we find angles, and that is called law of sines ambiguous case. And that is for another day and another video. All right, thanks a lot. I hope this helped you learn this.